Alright, this video is in order to help you guys out with, well, it's made in order to help you guys out with the How to Transform Your Parents worksheet. This is kind of drilling function transformations and getting you used to kind of an abstract representation of them. Obviously, a couple of these mathematical functions, and the only reason that they seem to be mathematical is because I told you they were, because they don't actually exist with the current framework we operate in. Is this guy and this guy. Alright, the rest of those are pretty familiar to you, but I just kind of want to get you guys used to an abstract representation. So I'm just going to work through, it was number 5 I wanted to do, and it was actually we'll do 5 and 6, okay? Alright, first thing, we're going to do 5 in red. Alright, so what you're asked to do is verbally describe the transformation. So what did I do to F in order to get to G? Alright, well the first thing is we see x minus 1 squared. So squared, this is our quadratic function. This is kind of the base function. The typical language uses the parent function. So now what's a little different is I'm starting with something already transformed. But I have x minus 1, which means it's technically 1 unit over to the right. Okay, because remember how it's opposite on the inside? Well, now I have minus 5. So it looks like what happened between here and here, right, was a subtraction of 4, right? And you don't see it, but there's actually a plus 0 here, and that makes things really obvious because now I see I added 3. Well, I'm going to go ahead and introduce different colors here just to make life easier. Well, this is something I did on the inside of the function, so I'm going to think of that as blue. And that's something I did outside of the function, so I'm going to think of that as green. So subtract 4 on the inside. Well, since I subtracted 4 on the inside of the function, it stayed inside. Right? We had the x minus 1 squared, x minus 5 squared. It stayed inside the parent function. What I would say here, since I did minus 4, I would say since it's on the inside, we're looking at either left or right. Okay? So, first thing I did, and it doesn't really matter what order you write these in necessarily, just kind of like verbally describing what happened. So the first thing I did was shift f of x 4 units. Now, the question here becomes, where am I shifting it? Well, I'm shifting it, since it's on the inside of the function, it's either going to be to the left or the right. So, let's just kind of get them both out there, and let's reason through which one we should choose. Right? So it's going to be one of these two. Alright, since it's minus, and it's on the inside, it's counterintuitive. So on the inside, it's opposite. So where you would think, alright, well, minus 4 on the number line, that means I would move it 4 units to the left. The function actually is moving 4 units to the right. So, we're going to say 4 units to the right. Alright, next thing, and we need to make sure that our language is correct here. Don't just say move it 4 units to the right, because we're not, I don't know what part of the function you're talking about there, because you could technically move specific coordinates but be doing a stretch or a compression, so you need to be clear here. Alright, now this plus 3. Well, since it's on the outside, it's intuitive. So I'm going to be shifting f of x 3 units. Well, since the change on the inside was either left or right, this change on the outside is up or down. So I would say 3 units up, and this is actually intuitive. Okay. Once again, I'm not trying to provide an entire lesson here. This is something you should be checking your notes on. This is just homework help. Okay. Same type of situation here, and I'm actually going to stay consistent with the colors from the get-go. So it looks like I started with negative 2, so I started with a minus 2, and I went all the way up to 3. From minus 2 to 3, well, that difference, it looks like I added 5. And then from 1 to negative 6, it looks like I subtracted 7. Since I subtracted 7, it looks like I shifted f of x 7 units downward. Alright, and then since I had a plus 5 on the inside, remember it's counterintuitive, I shifted f of x 5 units to the left. Right, plus 5 means I go the opposite direction. Okay, that's the idea of counterintuition. All right. Let me work through, and these problems only really addressed shifts. Let's talk about all of the transformations brought together. Okay. So for this one here, I kind of want to bring a little bit of everybody in there. I want to talk about 4. 4 is kind of an interesting one. It's kind of tricky, and I'm going to talk about 3. All right. So for 3, we're going to talk about the shifts first. All right. So from -1 to 3, looks like I added 4. All right. And as stated before, this is technically a plus 0. So it looks like I've got a -2 there. Looks like we had a little bit of an issue with that. All right. Now, there's other transformations that we have to consider here. Alright, so it looks like this negative on the outside is going to tell me something. There's a negative there, so that's something I have to consider. And then we'll use pink view. This 5/3 tells me something too. Alright, so let's start with the negative sign out here. Since there's a negative, and it's attached technically on the outside of the function, it's going to change the output. So what we have here is a reflection. Okay, if we're going to tack a negative on there, then we're talking about a reflection. Now the question is which axis? Well, it's counterintuitive here as well, because if I think about a graph, right, and I think about an absolute value type situation, if I take everything and make it negative, what it does is it actually moves down here. So it's almost like I'm reflecting it, well, it's literally like I'm reflecting it about the x-axis. So I'm reflecting this about x-axis. Okay? Once again, this is not a good standalone lesson. This should be, you should be kind of watching this along with following your notes. Alright, the next thing, since I'm talking about 5/3 here, 5/3. 5/3 is bigger than 1. So this is actually going to end up being a compression. Okay? So, I would say compression by a factor of 5/3. Okay, I'm not really interested in the depth of the language. If you really just stay consistent with what we're talking about in class, we're in a good shape. All right, now we talk about our transformations. Since we added 4, we would say shift 4 units to the left. And then for the last one, this is an obvious one, we would say shift 2 units downward. Okay? Now, number 4 is not obvious. Well, I guess there's one part that is pretty obvious. We know there's going to end up being, since I started at +3 and I ended at 0, I know that we're talking about a shift downwards 3 units. Now, where it gets a little crazy is when we look at this expression here, right? What did I do to get from x minus 1 to 1 minus x? Well, what did I do? Well, there's a couple ways we could think about this. Suppose I wanted to change the signs of this, right? Because here the x is negative, right? So let's say x here is positive and the 1 is negative, whereas over here the x is negative and the 1 is positive. It looks like I want to switch the signs entirely. So if I factor out a negative 1, then I'd have negative 1 minus x, right? So really what I'm doing here, obviously if I pull a negative 1 out of here, then I'm going to end up with negative x minus 1. So it looks like what I basically did, right, to get from here to here, the real change that took place was this guy. Now, it looks like this is actually on the inside of the function now, because what I could do is, if I really wanted to rewrite this, I'd have this shape here, and then I'd have negative x minus 1. And once I can learn how to use this pen. Alright, so now it looks like that other transformation, and we'll even call this the first transformation, is going to end up being, since the negative is technically on the inside of the function, well, actually not technically, literally, then what we have here is a reflection, because there's a negative sign, and it's on the inside, so it's counterintuitive. It's the reflection about the y-axis. Alright, so that's the first thing we're going to do. And then finally, the last thing we're going to do, because there's only 2 transformations in this one, conveniently enough, shift 3 units downward. Whoopsie, downwards. Or, just downward's fine. So we stay consistent with our language. Alright, I hope that this is helpful to you all. This is really just kind of a walk through a few of the problems. Good luck on the rest of the assignment.